Okay, today is going to be the first of our lessons on combining like terms. So today, our goals. When possible, I can write an equivalent expression that has fewer terms, and I can figure out whether two expressions are equivalent to each other. So if I asked you, could these expressions be equivalent to each other? 5a minus 2 plus 4a, a plus 2, and 9a minus 2. One way that you could tell whether they might be equivalent is by substituting in some different values for a. Let's try a equals 1. So every time I see an a, I'm going to put in the value of 1. So 5 times 1 minus 2 plus 4 times 1. And then I'm going to solve this expression. So 5 times 1 is 5 minus 2 plus 4. 5 minus 2 is 3 plus 4 is 7. When a equals 1 here, 1 plus 2 equals 3. That means the first and the second expression cannot be equivalent for each other because they're not equivalent when a equals 1. The last one, 9 times 1 minus 2, 9 minus 2 is 7. It might be equivalent to this first one because they both equal 7 when a equals 1, but that just means they work for one value of the variable. We don't know for sure, but they could be. Experimenting with numbers can tell us that two expressions are not equivalent, but it can't prove that two expressions are equivalent. So instead, we can use algebraic properties to create equivalent expressions. Today we're focusing on combining like terms, and when we combine like terms, we can add terms that have the same variable and the same exponent. I want you to think about what you've noticed before. If I told you to add 3 apples plus 1 apple, you would probably pretty easily be able to tell me that you have 4 apples. But if I asked you to add 3 apples and 1 puppy dog, you would be like, well, no, that's not just 4 apple puppy dogs, is it? You would just still have 3 apples and 1 puppy dog. So similarly, if I asked you to add 3x and x, you would have 4 x's. But if I said 3x plus y, that's simplified. You can't go any further. Let's use these principles and try to solve some problems. So I want you to write this expression with fewer terms. So from last week, we noticed that every time we're subtracting a number, we can rewrite it as adding the opposite. So this is the same thing as 10a plus negative 3 plus 4a. If we wanted to now, everything's adding, so we can rearrange using the commutative property and call this 10a plus 4a plus negative 3. Okay, notice we have a 10a and 4a. Those are like terms. That would mean we have 14 a's. But we have this negative 3. It's not like terms. 14a plus negative 3, that's basically as simple as it can go, though you may want to rewrite that as 14a minus 3. Let's try one with both x's and y's. So again, I'm going to rewrite this so when I see a minus sign, I'm going to change that to adding the opposite. Secondly, I think I'm going to reorder this so my x's are together and then my y's are together. Lastly, I'm going to combine my like terms. I'm going to put my x's with my x's and my y's with my y's. And I'm going to have negative 8x plus 21y. All right, well, what if I wanted to distribute and combine like terms, kind of putting together a few different skills? We could do that. We'd want to distribute first, because multiplication comes before adding. So I'm going to multiply the 2 by the negative 3 and by the 8. And the 8's not in parentheses, so it's just still being added. Negative 6 plus 2x plus 8. All right, this is all adding all together. If I want to, I can rearrange. So I'm putting my like terms together. Negative 6 plus 8 plus 2x. Negative 6 plus 8 is 2, and we have 2 plus 2x. So today, you're trying to write equivalent expressions that have fewer terms and also to be able to tell if expressions are equivalent to each other.